Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 78th question of the problem solving series and the third question of the topic linked list. The difficulty level for this question is easy and this question has been asked in Google, Meta, Microsoft, Amazon, Apple, Adobe and many other companies. Let's look at the question. Palindrome linked list. We know what is palindrome. When we get the same number, when we reverse it, the number doesn't change, like 1 2 2 1 4 5 4, right? Those kinds of numbers are palindrome. So we need to return if a number is palindrome or not. If it is palindrome, we return true, otherwise false, right? And we are given this list node head. Let's look at the example. 1 2 2 1, whether it is a palindrome or not, it is a palindrome, right? 1 2 2 1, if it is arranged, if it is reversed, we get the same number, right? True. So 1 2. So if we reverse it 21, this is a different number, okay? If it was 1 to 1, then it would have been a palindrome number, okay? So we would return here false. Now how do we solve this question? What comes to your mind in the beginning? We have this linked list. Now if we reverse it, whether the number would be same or not, how do we know? So if we reverse this number, we have seen in the previous question how to reverse a linked list. So if we reverse this, then since this is the linked list is a memory, right? So we have to take an extra linked list and then assign it as the same. Both the linked list should traverse. We'll create a new memory and then again assign 1, assign 2, assign 2, assign 1 and then reverse this. Okay, and then once we reverse it, we will see and check whether the numbers have changed or not. If it has not changed, then we return true. So in this way we can solve this question, but we'll have to create a linked list, so order of n space complexity, okay, in creation and then checking everything, like it would be done in order of 2n, but the time complexity, though it would be order of n, but we have to take an extra space to do this, okay? Same goes for this as well, right? Is there any other way? So what you can think, can we not take any extra space? Can the time complexity will obviously be order of n, because we have to traverse the linked list and see whether it is a palindrome or not. But can we do it in order of one space? How can we do it in order of one space without taking it? Okay, there is another way. If we take a stack, okay, and then we insert the elements up to half, okay, so we inserted 1 and 2. And after inserting up to half, we know how to find the middle of the linked list in the 75th question, right? We discussed. So this is 76th question we discussed, okay? Finding the middle of the linked list. So once we insert up to the middle elements, we have inserted it into a stack, and then we pop out and check with the next elements if it is same or not. We will be able to find out. If it is not same, we return false. So if it is same and the stack is empty, and then we can return it as true. But we have taken extra space. Stack order of n by 2 space we have taken, but we have taken extra space. So is there any way? First we have reversed the linked list, taken a new linked list, and then we have done it. Then we have taken a stack and we have inserted the middle of the linked list. Can we remove this stack, extra space stack, or extra reverse link? If we reverse it, then we are taking extra space of a new linked list and creating it. Can we combine both of this and do it in order of 1? So what if we get these elements here, okay, up to the middle? We have these elements 1 and 2. We find this up to here, and then we keep another pointer here. After finding the middle, we move it here, and this 1 and 2 what we have, can we reverse this? If we reverse this, once we reverse this, after reversing, if we check is it same or not without creating any extra space, can we do it? Yes. So if we find the middle of the linked list and then we find, after finding the middle of the linked list, we reverse this part of the linked list and then we check whether these are same or not. We can do it, right? So let's do it. Find the middle of the linked list. Then after finding the middle of the linked list, first part we will reverse it and then we will check after reversing the numbers are same with after the second part of the linked list. If they are same, then we will return true, otherwise we will return false, and it would be done in order of one space. So I will start. We know how to find the middle of the linked list, right? So what we can do is list node strict slow is equal to head, fast strict fast is equal to head. Let's take another list node temp, okay, so that we can take this and reverse it, okay. And temp is equal to head. Let's take now while fast not equal to null and fast next not equal to null, right? What we do, slow is equal to tortoise and here algorithm, slow is equal to slow next, fast is equal to fast ka next, right? Once we are done this, so now if fast is equal to null, right? So if fast is null, then what will happen? We will make temp is equal to slow. What we have done, you will understand now. Else we will make temp is equal to slow ka next. So what we have done here? So here in this case, when there are 4 elements, okay, so 1, 2, 2, 1, we need to reverse this much, okay. So here if it is slow and it is fast, then slow moves here, fast moves here. In the beginning, yeah, slow moves here, fast moves here. Then slow, fast next is not equal to null, so slow will be moving here, fast would be moving here, right? So in this case, temp is equal to, since fast is null, fast will be null here, so temp is equal to slow, right? So that means temp is here in this place, okay. So from here we can compare this part, we can reverse this part and then we can compare from here. Got it? Or we can reverse this part from temp view part we will reverse and then we can compare this to 1 and 2. Okay, this we can do. If the number was say 1, 2, 3, 2, 1. This is a palindrome. So slow was here, fast was here. Slow would be here, fast would be here. Then slow would be here, fast would be here. Then fast ka next is null, fast is not null, right? So what we will do, we will make temp is equal to slows next. What is slows next? This is slows next. So temp is here, right? So we will reverse this part, 2 and 1. Okay, so this will become 1 and 2 and then we will compare up to this much, okay, whether this is equal or not, till this doesn't get finished, because this is a middle element, okay. So this one we have done. Now what we will do, we will call reverse temp, okay. Temp is equal to, we'll call temp is equal to reverse temp, okay. So here this part would be reversed now. Once this is reversed, we will check while temp not equal to null, okay. If temp value not equal to temp value is not equal to head value. Okay, we will start from head. If temp value is not equal to head value, then we will return false. After reversing, they are not matching. Okay, for example, this one, or we can take another example. We'll discuss. If temp value is not equal to head value, we will return false. Otherwise, we will make temp is equal to temp next and head is equal to head next. Okay, and the number of elements would be same. We shouldn't worry about this because we have already found the middle element. Okay, we'll ignore if there is a middle element. If there is a if there are 5 elements, we'll ignore this. We will compare from here and it will go up to here. We don't need to worry about the size of the temp because it would always be equal to this or one less than this, and that one less would be an odd number. Okay, so moving temp equal to temp next, head is equal to head next, and if this condition we don't get false, that means all the reverse elements are same and we return true. Okay, so the link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 78th question of the problem solving series, Palindrome linked list in the lead code platform. You can see this example that we have discussed already, and you see they have asked to do it in order of n and order of 1 space, which we have discussed the last logic. So you can see here in the discussion section, I didn't code the reverse function because I just did it in my previous question, in the 77th question. Okay, so you can, let's see the code walkthrough. We have taken this temp is equal to head, slow equal to head, and first equal to head. We have find the middle element. Okay, so here we have used this logic so that we can compare the next half of the middle elements. We'll reverse it and then we'll compare it with the first half. If it is same, that means it is palindrome. If it is not same, then we'll return 0, that means false. Okay, and this reverse logic, you know, right? If you've not seen the 77th question, I'm explaining it here again. So here we have this ptr is equal to slow, previous equal to null. We take 3 pointers, and while we traverse this, and at every stage we reverse the link from like if it is 1 and 2, so we'll reverse this 1 would be pointing to null, and in the second stage 2 would be pointing to 1, and then this 2 1 will get, once we get this 2 1, so our temp will have 2 1, and then we will check one by one. Temp's value is 2 in the beginning, and this this 2 1 was there. We gave this 2 1. Okay, so this 2, and so this 2 1 is actually reversed to 1 2, and then we are comparing this 1 and 2. Okay, not this 1 2. We reverse the second half. Okay, so this becomes 1 2, and then we compare 1 is equal to 1 and then 2 is equal to 2. That's why it is palindrome. Okay, please check the 77th question to know how we reverse the linked list. Okay, let's submit this code. You see all the test cases have passed, and I hope you have understood this question. See you all soon in the next video, where I'll be explaining the 79th question of the problem solving series and the 4th question of the topic linked list. Jai Jinendra.